Find the volume of the solid of revolution generated when the region bounded between the curves y equals x squared, y equals 0, and x equals 1 is revolved around the y-axis. Okay, so I'm going to try to sketch this region. So y equals x squared is pretty familiar. Looks like this. And then y equals 0 is the x-axis. And x equals 1 is a vertical line at 1. So I'm looking at this region bounded by those three curves. And I want to rotate it about the y-axis. So it's a little different than the last one. Last one I rotated about the x-axis. So if I pick a random spot along the x-axis, call it x, and draw a little representative rectangle there, the height of that rectangle is x squared, because that's the height of the curve. That rectangle is parallel to the axis of revolution, whereas last time it was perpendicular. So if your representative rectangle is parallel to the axis of revolution, you have to either draw your representative rectangle in a different way so that it's perpendicular, or use a different method called the shells method. So this is the method of shells. So what I'm going to do is imagine taking this rectangle, this little pink rectangle. It's got a little bit of thickness, delta x. Rotate it around the y-axis, and you're going to create a cylinder with a very small thickness. So I'm going to draw a picture of that cylinder. Kind of looks like a paper towel roll. Okay, so there's my cylinder. The height of that cylinder is x squared. It's the height of my pink rectangle from the picture to the left. And the thickness is delta x. And then if I want to know the volume of this thing, I have to remember that if I unroll this, I'm going to get a rectangle that has a little bit of thickness. So that's delta x. The height is still x squared. Okay, and then the length of that rectangle is the circumference of this circle when you unroll it. So the circumference of that circle unrolled is going to be 2 pi r. And the radius of that circle is x. That's the distance from the axis of revolution to the rectangle. So it translates here as x, and over here 2 pi x. Okay, so the volume of my slice, the volume of my single slice, is going to be the volume of a rectangle is base times height times depth. So this is going to be 2 pi x times x squared times delta x. So that's the volume of my shell. I'm going to add up all of these shells at lots of different x values between 0 and 1. So the volume total is going to be, I'm summing an infinite number of these shells. So each slice is going to have volume 2 pi times xi cubed delta x. And I'm going to take the limit as n goes to infinity of this sum. And that translates to an integral. The integral from 0 to 1 of 2 pi x cubed dx. So this is 2 pi times the integral from 0 to 1 of x cubed dx. That's 2 pi times 1/4 x to the 4th, evaluated from 0 to 1. 2 pi times, if you plug in a 1, you get a 1/4. Plug in 0, you get 0. 2 pi times a 4th is pi over 2.